Assalamu alaikum. I am Arijanur from Department of Physics, University of Agriculture, Faisalabad, Pakistan. I have just completed my master degree under the supervision of Dr. Shazia Shukrullah. Today I will discuss about the production of hydrogen from the ethanol under visible light by using nickel-coated rare earth titanate photocatalyst. Here is some outline in which the first of all I will explain about the research background. After this I will explain the research objective, and line wise I will explain all the things that are listed here. Okay, so let me now to move on the first part, which is the research background. Basically, since few decades, increase the attention is being paid to the global climate and the public health problem. Decrease in the fossil fuel, increase the energy demand, and increase in the pollution. Therefore, automotive sector had to work hard on the pollution control. For this, catalytic converter on gasoline fuel-based engine are designed. However, in order to overpass the regulation on the carbon dioxide emission, the development of both engines and the alternative fuel is required. The impact decrease in the fossil fuel reserves and the continuous energy demand make it necessary to develop and adopt the renewable and clean energy alternative independent of fossil fuel. Among of them, the use of the fuel cell has been recognized as one of the most promising technologies that produce the clean energy. Basically, in fuel cells, the hydrogen and the hydrogen and the oxygen react to produce the electricity, heat, and the water. Okay, now move on to the second thing, which is the research objective. The objective of the work was to deal with the catalytic process for producing a renewable hydrogen as a clean energy source for the efficient generation of electricity through the fuel cells. To develop the high active catalyst to ensure the full conversion of the ethanol with the minimum production of undesired byproducts at the lowest possible temperature, and to produce the a series of the nickel-coated lanthanum titanate at the different temperature. To achieve all the objective, I am going to tell you about how the hydrogen produced from the fossil fuel. Basically, hydrogen from the material that contain it like ethanol, methanol, hydrocarbon, and many other sources is obtained from the fossil fuel processing technologies and the methods. They are the basic three types of the technologies that are used to produce the hydrogen from the hydrocarbon fuel. The first one is ethanol steam reforming. After this, the autothermal steam reforming and the partial oxidation. For this technology, we can use different catalysts, but the one of best one is the nickel-based catalysts that are widely used in the industrial process for the hydrocarbon steam reforming. Nickel is known as due to its ability to break carbon-carbon bond, participation in water gas shift reaction, cork formation, and the effective in methane reforming. Among all the renewable feedstock alternatives, the ethanol is very attractive because of its high content of the hydrogen, availability, low price, and the handling ease and the safety. But one of the most important reasons for choosing the ethanol is that it can produce renewably in large quantity from the many biomass sources like energy, plant waste material from forestry residue material, and therefore it cannot increase the greenhouse effect. For make the catalyst, uh, here's the introduction of the ethanol steam reforming. It is basically an endothermic process in which the heat is supplied to the process to proceed the reaction. The main reaction of the ethanol steam reforming is the water gas shift reaction, in which the carbon monoxide and the steam reacted in the presence of the catalyst to produce the carbon dioxide and the more of hydrogen. This is the reaction pathway of ESR, in which the ethanol is decomposed into the many products. They are the different method used to make the catalyst, but the method I was adopted is the Piccini sol gel method. It is also called the sol gel or wet chemical method. It is easy and the simplest way to obtain the nano powder. In the catalyst preparation, there are the different type of the chemicals that were used are listed here. First one is the titanium isoperoxide, citric acid, ethylene glycol, nickel nitrate, lanthanum nitrate, ethanol, and the water. This is a schematic diagram of the catalyst preparation. The prepared catalyst was used in ESR activity. The ESR activity was performed by using these parameters and the conditions that are listed here. This is the schematic diagram of ESR. The ethanol conversion product yield and the product selectivity by the ESR activity are given here in a table. All these values come from the ESR activity. Figure 1a and the 1b show the water gas shift reaction at the two different temperatures. The water gas shift reaction is used to reduce the amount of the carbon monoxide or manage the ratio of the hydrogen and carbon monoxide. As decrease in this ratio with increase in temperature due to exothermic nature of the reaction was observed. The hydrogen selectivity as the function of the temperature in the ethanol stream deforming is shown in the figure. You can see all the results that come from the ESR test. This is the graph of ethanol conversion and the hydrogen yield. The properties of the prepared catalyst like particle size, crystal plane, phase purity and morphology studied by using the different techniques like STEM, UV visible spectroscopy, X-ray diffraction, FTIR and many others. The first one is FTIR spectroscopy. It is a powerful optical spectroscopy based on the vibration measurement of excited molecule by IR radiation at the specific wavelength length, which identify the vibration characteristics of the chemical functional group in the sample like OH, CH touching, OH bending and many others. FTI spectroscopy provide the information on molecular structure, chemical environments, orientation and the conformation of the polymer chains. It is also a best method for the identification of the molecular structures such as a functional group and the bonds. There are the different type of the functional group that identify FTI spectra of the nickel loaded lanthanum titanate as given in table. After this, I will explain about the UV visible spectroscopy. That technique is also used for the it is also important characterization technique used for the to study the optical properties of the material. The absorption spectra and the values of the band gap is given in the figure. As we can see that the value of the band gap decreases as the temperature increase, means that the relation of the band gap and the temperature is inverse. The value of the band gap of the nickel loaded lanthanum titanate that is calcinated at 600 degrees Celsius is 3.6 electron volt, and the second band gap value is the 3.48 electron volt. One of the most significant technique in the nanoscale research is X-ray powder diffraction measurement. It is a rapid analytical technique primarily used for the phase identification of crystalline material and provide the information on the unit cell dimension. In this figure, the different value of the Miller indices are given in the peak of the XRD spectra. With the help of this value, we can find the structure of the material, and the monoclinic structure was identified by all these values. The different values of the angles are given in which the alpha and the gamma are equal to 90 whereas the beta is equal to 97.6. There is another characterization technique which is stamped. It is used for the used to find the particle size of the material. As you can see in the picture, the large area or a darker area in the graph show the lanthanum titanate, whereas the lighter part show the nickel oxide, and the average particle size of the nickel loaded lanthanum titanate that was observed is the 40 to 60 nanometers. This is also the STEM image of the nickel loaded lanthanum titanate at the 800 degrees Celsius, the magnification of the 25K. At the last, there is a conclusion which explained that the monoclinic structure was confirmed by the XRD analysis with the 26.7 and 29.9 nanometer crystalline size. The particle size was confirmed by the STEM, which is the 40 to 55 nanometer. The FTI spectra also confirmed the different functional group like OH, CH, and the cyano. The different significant change in the band gap confirmed by UV analysis. The calculated value of ER, as I explained, 3.60, 3.48 electron volt. The ethanol conversion of the end product yield and the product selectivity was observed by the ethanol steam reforming activity. The catalyst that was calcinated at the 600 degrees Celsius give the lowest yield of the hydrogen as compared to the catalyst that calcinated at the high temperature, and the conversion of the ethanol was also observed in this respect. So this is all about my presentation. Thank you for listening.